Hey gang, Mr. Cruze here with a video lesson for you. Today I'm going to teach you a little bit about probability, okay? So just a couple quick definitions for you and then we'll dive right in. So probability basically measures how likely it is that something will happen, okay? How likely is it that Mr. Cruze will wear a sweater vest on a Monday? You know, things like that. Like we can measure those sorts of things. What's the probability of getting a 6 if I roll a die? Things that you're probably commonly used to. What's the probability I win the lottery? Basically, it's a fraction, so it's a ratio, and that ratio is the number of favorable outcomes out of the total number of possible outcomes. So a common example is what's the probability I get a heads on a flip of a coin? Well, on a coin, there's two faces, right? The heads and the tails. So there's two total possible outcomes. I could get heads or tails. So that's the denominator of my fraction. And the number of favorable outcomes, well, there's only one head, so it'd be 1 out of 2, which is where we get the 1/2. Okay? If you do leave it as a fraction, be sure to write it in lowest terms. You can also turn things into percents, but for the most part, I would just suggest leaving things as fractions. All right? Anytime something happens, like flipping heads or rolling a 6, we call that an event. That's an outcome, right? That's an outcome that we're looking for. Sometimes it can be a collection of outcomes, like maybe I'm looking for rolling an odd number or an even number or drawing a heart. That's a collection of outcomes. There's more than one thing. Okay? And the outcome, well, that's sort of random. We love the idea of randomness. So we don't know what the outcome is going to be. We just know that it's uncertain. But we can kind of, in the long run, predict what's going to happen. All of your possible outcomes that you have, we call that the sample space. Okay, it's basically a set of all the possible outcomes that could happen. So let's take a look at number 1 here. We have a spinner. Maybe not a usual spinner. You know, there's some repetition, but it's okay. We're going to use that spinner. I want to know what's the probability if I use this spinner, what's the probability I get a 1? Okay? Well, I notice my favorable outcomes, there is only one 1. Okay, so there's only one way that I can get that. Out of, there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So my probability is 1 out of 8. Okay? Or, if you want to write it as 0.125, you can do that. If you want to write it as 12.5%, I wouldn't worry too much about rounding it. I would personally just leave it 1/8 and be done with it. Okay? What about probability of 2 or a 6? Okay? So what's my favorable outcome here? Well, the only outcomes I care about in this particular problem, I care about a 2, obviously. If I can get a 2, I win, right? Or I can get a 6. Obviously, I can't get both in one spin, but I can get a 2 or a 6, and I will still win. Okay? Well, it turns out between the 1, 2, and the 3 6s, there are 4 favorable outcomes. That's what I want to happen. And then there's still 8 total. 4 over 8. Don't leave it like that. Leave it as a reduced fraction, which would be 1/2. If you want to write it as 0.5, you can. Or if you want to write it as 50%, you can as well. Any of those answers will be fine. Pretty basic, hopefully. Find the probability of choosing an M from a set of cards with one letter from the word mathematics written on each card. You choose a card without looking. So we have cards. Each one has a different letter on it. M-A-T-H-E, M-A-T-I-C-S. And I'm going to draw one card at random. What's the probability I get an M? Well, again, look at favorable outcomes. How many favorable outcomes are there? Well, I see 1, 2 M's in the word mathematics. So there's 2 favorable outcomes. And the word mathematics is how long? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that would be 2 out of 11. Frankly, I would leave it just like that. But if you want to write it as a decimal, it's like 0.1818, so 0.182 maybe, or 18.2%. I wouldn't care either way. But 2/11 would probably be the best answer. It's easiest to write. All right, for the following examples, list the outcomes. All right, so we're going to list our entire sample space. We're going to list everything. We're going to use these little set brackets, these little curly, sideways flying birds things, because technically the sample space is a set. It is a set of all possible outcomes. So, number 3 says spinning the spinner in example 1. So I'm going to write the sample space for the spinner in example 1. So basically, what kinds of outcomes could I get from this spinner? And usually you want to write them in order, although sometimes, there is no particular order. But here, since we have numbers, we can do it in order. And you don't want to write repeats, okay? We don't want to include the repeats because they're already part of the set. So what numbers do I see? Well, I see a 1, I see a 2, I see a 3, I see a 4, there's a 5, and there's 3 6s, but I don't have to write all 3. I can just write that. There's the list of my sample space. Okay? Okay, so example 4, drawing a letter in example 2. Well, we have the letters in the word mathematics. We have M, we have an A, we have a T, we have an H, we have an E, we have another M, but we already wrote M, so we don't have to write it again. Another A, another T, mathematics, there's an I, a C, and an S. There's your sample space. Those are all the possible outcomes you could get. Again, since we're not writing the repetition, that doesn't mean that M can't appear twice, A can't appear twice, T can't appear twice. It just means since we're just writing the outcomes, we don't have to write the repeats because all of these things are possible outcomes. Some may have a higher chance than others, but they're all possible outcomes. How about tossing a number cube? Well, that's just a die. That's a fancy math way of saying a die. Well, a standard 6-sided die, we have numbers 1 through 6. There are other dies. I have some games that have die with different numbers on them, but we're just tossing a normal number cube. How about choosing a digit at random from 55,238,175? Well, what kind of numbers do I see? I see a 5. I see another 5, but I'm not going to write it again. A 2, a 3, an 8, a 1, a 7, and then I think that's it because the 5 again repeats. That's sample space. You're literally just listing every outcome. Okay, for the examples below, find the probability. Use the spinner from example 1. So we're going back to example 1 now. I want to know what's the probability I get a 6. Well, if you look at your spinner, and you guys have an easier time of this than I do, there are 3 6s out of 8 possible. So I'm just going to leave it as a fraction and not worry about writing the percentage. How about probability of 1 or 2? Well, remember, that can be a 1 or it can be a 2. It doesn't matter. Either way, I win. So there's 2 possible, successful outcomes out of 8. I'm going to reduce that fraction to be a probability of 1/4. And the probability of an odd number. So odd numbers, think numbers like 1, 3, 5, 7, blah, 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 blah. And it looks like I see 1 odd number, 2 odd numbers, 3 odd numbers out of 8 total. Hopefully this is pretty simple for you. Honestly, the hardest part is just figuring out what they want and reducing the fraction. All right, so here's some more. Find the probability that a student chosen at random from a class of 8 girls and 12 boys is a girl. So what's the probability I pick a girl out of this particular class? Well, there are 8 girls, so 8 successful outcomes. Out of 8 plus 12, 20 students total. And again, once I'm going to reduce that, I can divide both of those numbers by 4, and I get 2/5, 40%. 40% chance of picking a girl. Find the probability of selecting a vowel. Vowel, by the way, in case you're not clear, is A, E, I, O, and U. We will not include Y for this class, okay? So selecting a vowel if a letter is chosen at random from the word winter. Well, how many vowels are in the word winter? Well, I see an I and I see an E. So there are 2 successful outcomes there out of 6 letters total because the word winter is 6 letters. And that it reduces to a fraction of 1/3. And number 12, a day of the week is chosen at random. So think about the days of the week: Sunday, Monday, Tuesday, all the way across. Find the probability it has exactly 6 letters. Well, okay, so I think about my days of the week. Sunday has 6 letters. Monday has 6 letters. Tuesday has 7. Wednesday has a bunch. Thursday has 7. Friday has 6, and Saturday has 8. So the only days that have 6 letters are Sunday, Monday, Friday. That would be 3 out of 7 days. Find the probability it has fewer than 6 letters. Well, again, let's go back through our list here. Sunday, Monday, Friday have exactly 6. Tuesday has more than 6. Wednesday has more than 6. Thursday and Saturday also have more than 6. There are no days that have fewer than 6 letters. There are none. So how many successful outcomes are there? Well, there's 0 out of 7 days. Don't leave it like that, though. Go ahead and write 0. The probability is 0. Probabilities can be 0. That's an important thing. What's the probability it has more than 6 letters? Well, how many days have more than 6 letters? That would be Tuesday. That has 7. There's Wednesday, which has 9. There's Thursday, which has 8. And there's Saturday, which also has 8. Okay? So, there are 4 out of 7 days of the week that are more than 6 letters. All right, folks, that's it for me. Your assignment is to do the odds on the worksheet that is stapled to your notes. If you have any questions, do not hesitate to email me, tweet me at Mr. Cruze Math, or message me on Canvas. I will be glad to respond to your questions. Please be nice for the sub. You may check your answers on the worksheet that's attached to the board. And I will see you guys Monday. Have a great weekend.